With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. In this problem it is saying that a rod of AB of length 2L, mass M is lying on a horizontal frictionless surface. A particle of same mass small m traveling along the surface and hit the rod at distance L by 2 from the center of mass with a velocity V0 in direction perpendicular to the rod and stick to it. Now here it is asking that angular velocity of the rod just after the collision. So in this given problem there is I can write that here F external equal to 0 as well as torque external equal to 0. Thus we can apply P linear momentum conservation, and this is angular momentum conservation. So this concept I'm going to use here. So here this was the initial center of mass. Now after collision, let the center of mass is C2. Here this is C2 and its location will be after collision will be here. It will be from this point O, that will be L by 4, and from this side it will be also L by 4, because here mass of both interacting system or particle are same. That's why the center of mass will be lying at the middle point of the geometrical center. Now from here I can write here that P initial will be equal to P final. So if I use momentum conservation here, that is mv0, it is striking with velocity v0 will be equal to 2m vcm. So from here velocity of center of mass will be comes out to be 2. Now it is asking in the problem that we have to calculate the final angular velocity here. So here L initial will be equal to L final. Now further solve this. So L initial will be mv0 L by 4, and here that will be moment of inertia of rod about O plus moment of inertia of rod about C2 plus moment of inertia of m mass about C2 equal to omega into omega f. So now let's put their corresponding value here. So this will be m initial rod length was 12 and about O, its moment of inertia will be ml square by 12. So here L is 12. Similarly ml moment of inertia about C2 will be, I'm using here parallel axis theorem directly to calculate moment of inertia about C2. So here this length will be ml by 4 whole square, and this will be also ml by 4 whole square into omega f. So if we solve this, on the right hand side this is left hand side, this is mvl by 4, and here I will get ml square by 3, and this will be comes out to be ml square by 8 omega f. So further we solve, this will be 8 3 11 ml square over, it will be 24 omega final, and from left hand side, on the left hand side I will get, and after solving this will be 6. So finally I will get here that omega final will be equal to 6 v0 by 11 L. So this will be the final answer of final angular velocity. So if we look at the option, our option number first will be correct answer of this given problem. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.